I want you to imagine a building for a second.
Okay, a building.
Yeah, but picture a facility the size of like 4 or 5 professional football fields.
That's massive.
Right. And inside this massive structure, there are no assembly lines, there are no workers building cars, no heavy machinery stamping steel, nothing like that.
Okay, so what is it?
It is filled wall to wall with hundreds of thousands of screamingly loud computers, just
Yeah.
racks and racks of them.
Ah,
And the ambient temperature in there is so hot that it requires a cooling system pumping like millions of gallons of water.
yeah, the heat is unbelievable.
It's wild.
Yeah.
And the entire facility draws so much raw electricity that it literally requires its own dedicated power plant to function,
Yeah.
like just for this one building.
Just to keep the lights on and the servers humming.
Exactly. Now, I want you to realize that this colossal, resource-devouring factory isn't manufacturing a physical product.
No, it's not making cars.
It's manufacturing thoughts, it is processing logic, and the world's biggest tech giants alone are projected to spend over $600 billion on infrastructure exactly like this annually by this year, 2026.
600 billion every single year.
Every year, just laying the groundwork. I really want that image to like sink in for you as you listen to this. Because when we talk about artificial intelligence today, we have to completely strip away this old, outdated idea we have of AI.
Right, the whole sci-fi movie concept.
Yeah, or just, some clever chatbot living on your phone. AI is right now the literal physical foundation of modern economic power.
It really is a massive paradigm shift. I mean, when you hear a number like $600 billion annually, you have to fundamentally rewire how you think about technology.
Because it's not software anymore.
Exactly. That kind of capital isn't being spent on writing code. It is being spent on concrete.
Right.
It's being spent on structural steel, on laying thousands of miles of fiber optic cables, on securing land rights, and like you said, overhauling entire regional energy grids. It's physical, highly physical. We are talking about the physical world being violently reshaped to accommodate a digital capability. So that era of, a couple of brilliant coders in a garage coming up with a single elegant algorithm and changing the world.
Yeah, the classic Silicon Valley myth.
Right. That era is effectively over. What we are looking at now is a vast, mind-bogglingly complex web of heavy infrastructure, monumental capital deployment, and really intense geopolitical maneuvering.
It's industrial.
We are talking about industrial scale mobilization here.
Okay, let's unpack this, because we have an incredibly dense stack of material today.
We really do.
We are looking at a comprehensive global map of the AI landscape. And specifically, we have data outlining the distinct strategies of the 10 nations that are currently leading this massive AI revolution.
We top 10 players.
Exactly. And our mission for this deep dive is to decode this global race. We are going to unpack the very distinct and sometimes totally diametrically opposed strategies of these nations.
Because they are definitely not all doing the same thing.
Not at all. And most importantly, we are going to help you, the listener, understand how these massive investments are actively shaping the world you are living in right now.
Because it is. It's happening around you.
Yeah, this isn't happening in a vacuum. It's happening in your economy. It's shifting your global supply chains, and it is actively writing the future of your job market.
Absolutely.
And, going back to that infrastructure point, that's what really struck me right out of the gate. The sheer physical scale.
It's staggering.
It is. We aren't just talking about software licenses. We are talking about raw, unadulterated electrical power and just massive data centers.
Exactly. We are looking at a race that requires the kind of national mobilization we usually associate with, like the energy sector or heavy manufacturing during wartime.
Wow, wartime, really?
Oh, yeah. The countries that are leading this charge aren't just the ones with the best programmers anymore. They're the ones securing the global supply chains for raw silicon.
The actual rocks in the ground.
Yes. The ones building the energy grids capable of supporting supercomputers,
Yeah.
and the ones completely reorganizing their national education systems to produce the talent required to run it all.
It's everything.
It is a full-stack, comprehensive geopolitical competition, and the stakes are absolute.
Right. And you cannot even begin to map out a global race of this magnitude without first looking at the absolute heavyweights.
The big two.
Yeah, we have to look at the two massive frontrunners who are completely setting the pace and, frankly, defining the stakes for everyone else on the planet. I'm talking, of course, about the United States and China.
The two undisputed titans in this
The
space.
titans.
And while they are both operating at the very pinnacle of this technology, their approaches to maintaining and expanding that dominance could not possibly be more different.
Night and day.
Truly, they are operating on two entirely different philosophies of innovation.
Okay, let's start with the United States. The data shows the U.S. is the undisputed leader across almost every single dimension you can measure.
Top of the board.
Yeah. We are talking overall investment, innovation, physical infrastructure, and human talent. The numbers here are just staggering. In the year 2025 alone, the U.S. invested over $470 billion in AI-related sectors.
$470 billion.
Just wrap your head around that. That's so far beyond what any other country is doing. It almost requires a completely new scale just to graph it.
It breaks the chart.
It literally does.
Oh.
But the material also points out why the U.S. leads. And it's not just the sheer amount of money. It is this incredibly potent, layered ecosystem.
That ecosystem is the key, because it isn't just one monolithic entity driving the bus.
Exactly. You have these massive private mega companies, your Googles, Microsofts, Amazons, OpenAI, and they are driving the software development and the actual training of these massive AI models.
Right, the household names.
Right. But then, sitting right beneath them, you have a wildly robust semiconductor ecosystem.
The hardware guys.
Yeah, you have companies designing the absolute bleeding-edge brains of the operation. And you pair that with unparalleled cloud computing infrastructure like AWS and Azure, which provides the actual environment for all of this data to live and breathe in.
Yep.
And then, feeding the whole machine from the bottom up, you have elite university systems, Stanford, MIT, pumping out the absolute best engineering and computer science talent in the world.
And what makes the U.S. system so dominant is how entirely synergistic those layers are.
What do you mean?
Well, you have academic institutions doing groundbreaking theoretical mathematical work, right?
Okay.
Then the top talent from those university labs almost immediately flows into the private tech giants.
Because they can pay them millions.
Exactly. Then those tech giants, who have massive capital at their disposal, use that money to fund the semiconductor companies to design even faster, more efficient chips.
It's a feedback loop.
Yes. And then those new chips are plugged directly back into the massive cloud infrastructures built by those same tech giants, which allows them to train even larger, more capable AI models. Wow.
It is an incredibly aggressive, self-reinforcing loop of innovation and capital.
But the defining characteristic here, right, is that it is fundamentally driven by the private sector.
Oh, heavily.
The government is there, sure, maybe handing out some grants or passing policy, but the actual engine of this dominance is private competition.
Yes.
These mega data centers we are talking about, the ones training the most advanced models in the world, those are corporate assets.
Absolutely. They're owned by shareholders.
Right. Which brings me to the analogy I couldn't stop thinking about while going through this. Tell me if this tracks.
Let's hear it.
The U.S. strategy feels like a massive, privately funded gold rush.
Okay, a gold rush.
Yeah, you have all these incredibly well-funded prospectors, the tech giants, and they are all racing each other to the exact same mountain. The fastest runner wins. The one who builds the sharpest pickaxe wins.
Right.
It is inherently chaotic. It is fiercely competitive. Microsoft is trying to beat Google. Google is trying to beat Amazon. And because of that cutthroat competition, it drives incredible speed. It does. It forces everyone to sprint.
But then you look at the other side of the board. You look at China.
And China is the single biggest challenger to that U.S. hegemony.
Right. And their approach is an entirely different universe.
Totally.
The data shows China invested over $119 billion in AI in 2025. Now, clearly, that is less than the U.S.'s $470 billion.
Significantly less.
Yeah, but China's strategy isn't about chaotic, fragmented private competition.
Right.
It is a massive, heavily coordinated, top-down, government-driven strategy.
Very deliberate.
Their stated goal is to become the absolute global AI leader by 2030, period. And they already lead the world in AI patents and research publications.
Which is a huge metric.
Huge.
Yeah.
And they do rely on domestic powerhouses, companies like Baidu, Alibaba, and Tencent. But those companies operate under a very unified, strict national directive.
They all march to the same drum.
Exactly. So, to continue my analogy, if the U.S. is a chaotic gold rush, China feels like a highly coordinated state-sponsored mega infrastructure project, like building a national highway system, or like the Hoover Dam. Every single piece is meticulously planned from the top down.
That is a very apt comparison. The Chinese model is about aligning every single lever of national power toward one singular technological goal.
So looking at these two models side by side, I have to ask a blunt question.
Go for it.
Does the U.S.'s reliance on competing private companies actually make it vulnerable compared to China's unified execution?
Vulnerable how?
Well, I mean, in a gold rush, a massive amount of energy is wasted just fighting with each other. Microsoft and Google are building redundant systems just to compete. But in a state mega project, every single ounce of energy, every single dollar, pushes the exact same boulder up the hill. Doesn't that make China's model more efficient?
What's fascinating here is that you are touching on the absolute core debate in global technology policy right now.
The big question.
The biggest you are asking. Is centralized planning more effective than free market competition for a technology as fundamental as artificial intelligence? Let's break down the mechanics of both. The U.S. model, the gold rush, absolutely accepts a high degree of redundancy and inefficiency.
Right.
As you said, you might have 3 different companies building nearly identical billion-dollar data centers and training nearly identical language models.
Which seems nuts. It seems like a massive waste of capital.
On paper, it looks terribly inefficient. It does. But the underlying philosophy of the free market is that this exact friction, this ruthless competition, is what breeds faster, more resilient innovation.
Okay, resilient how?
Because if one single company makes a catastrophic misstep in their research or builds the wrong kind of infrastructure, another company is right there, fully funded, ready to capture the market.
So there's backups.
Exactly. It is highly resilient because there are multiple independent points of failure. Now, the Chinese model, the mega project, minimizes that redundancy. It aligns the capital, the talent, and the supply chains with laser precision.
So it's much faster in a straight line.
Exactly. When you are dealing with something that requires massive physical infrastructure like building out energy grids or securing domestic chip manufacturing's centralized capital deployment, can literally move mountains in a fraction of the time it would take a private market to negotiate the contracts.
Right, because nobody has to argue over zoning laws if the state just says build it.
Exactly. But the vulnerability of the top-down model, historically speaking, is rigidity.
Rigidity?
Yeah. If the central planners at the top misjudge the technological direction, say, they bet heavily on one specific type of algorithm, and the global paradigm suddenly shifts to another, the entire national ecosystem goes down the wrong path simultaneously.
Oh, man. Like putting all your chips on red and the ball lands on black.
Precisely. The U.S.'s ability to continually push the very frontier of what AI models can conceptually do is a testament to the sheer brute force of competitive private capital.
Right.
But China's ability to marshal resources to rapidly deploy technology across their entire society is a testament to state-led execution. We're essentially watching 2 diametrically opposed philosophies of human organization trying to solve the exact same technological puzzle.
And a huge piece of that puzzle for China, which the material highlights heavily, is this desperate focus on self-reliance, particularly in hardware.
That self-reliance is the critical pivot point in China's current strategy.
Yep.
You have to look at the geopolitical context.
Right.
The U.S. has placed severe export restrictions on the most advanced AI chips, preventing them from being sold to Chinese companies.
Wait, let me make sure I understand the mechanics of this.
Yeah.
The U.S. government is literally stepping in and telling private companies, you cannot sell your best computer parts to China.
Yes, exactly.
Why? Just to slow them down.
It is entirely about national security.
Okay.
Because AI depends so absolutely heavily on these specific advanced chips, being cut off from the global supply chain of top-tier hardware is an existential threat to an AI program.
I mean, no hardware, no AI.
Right. And the U.S. views AI not just as a commercial tool, but as a dual-use technology.
What does that mean, dual use?
It means a system that can optimize a logistics supply chain for an online retailer can also be used to optimize military targeting systems or break advanced cryptography.
Oh, okay. Yeah, that's terrifying.
Exactly. So by restricting the chips, the U.S. is trying to choke off the physical fuel required to train those advanced models.
So how is China responding to being cut off from the fuel?
By aggressively building their own refineries, to use your analogy. They're rapidly developing alternatives to the advanced chips designed in the U.S.
By training from scratch.
Essentially, yes. They're trying to build an entirely domestic AI ecosystem from the sand up. They want to secure the fundamental physical building blocks of computation entirely within their own borders, insulated from the foreign policy shifts of
That
Washington.
is a perfect transition. Because both of these massive superpowers, despite their totally different philosophies, are crashing headfirst into the exact same physical bottleneck.
The hardware.
The hardware.
Right.
We spend so much time talking about AI living in the cloud. We talk about it like it is this invisible, ethereal, magical thing floating above us.
Right, up in the sky.
Yeah. But China's massive push for hardware self-reliance and the U.S.'s $600 billion infrastructure spend completely shatters that illusion.
The cloud is just a building.
Exactly. The cloud isn't in the sky.
Yeah.
The cloud is just a massive windowless building full of incredibly loud, incredibly hot computers. AI is overwhelmingly physical.
It is arguably the most hardware-intensive technology humanity has ever developed.
Wow.
And that brings us directly to the physical reality of AI and what is currently being described as the global chip war.
Right. Let's dive deeply into this semiconductor race, because I think people hear microchip and they just think of like the little green squares inside their laptops.
Sure.
But the hardware driving AI is fundamentally different, isn't it? The material is very clear.
Wow.
AI depends entirely on advanced chips.
It's completely dependent.
But here is the critical distinction I want you to unpack for us. The U.S. absolutely leads in chip design. Companies in California are designing the architecture of these miraculous processors.
Drawing the blueprints.
Yes, the blueprints. But the actual manufacturing, the literal physical printing of the silicon at the microscopic level, is utterly dominated by Taiwan and South Korea.
Utterly dominated.
So before we get to the specific countries, can you just explain the how? Like, why can the U.S. design a chip, but they rely on facilities across the Pacific to actually build it? What is a chip, really?
It's a fantastic question, and it's really the core of the entire geopolitical tension. Let's break down the hardware. First, you have to understand the difference between a traditional computer chip, a CPU, and an AI chip, which is usually a GPU, or graphics processing unit.
Okay, CPU versus GPU. What's the mechanical difference there?
Think of a standard CPU, the chip in your laptop, like a single, absolutely brilliant mathematics professor.
Okay, a professor.
Right. If you give that professor a brutally complex multi-step calculus problem, they will solve it very quickly.
Right, because they're a genius.
Exactly. They are designed to do complex tasks sequentially, one step at a time, very fast. That is great for running an operating system or a word processor.
Makes sense.
But AI doesn't need to do one highly complex math problem sequentially. AI, specifically the training of neural networks, requires doing millions and millions of incredibly simple math problems at the exact same fraction of a second.
Oh, so the professor is actually the wrong tool for the job.
Exactly. The professor is too focused on one thing. So instead of one brilliant professor, a GPU, the AI chip, is like a stadium filled with 10,000 middle school students.
Okay, that's quite a visual.
Right. Now, individually, they aren't going to solve advanced calculus. But if you give all 10,000 of them a basic arithmetic problem simultaneously, they will process a massive volume of basic calculations in parallel, instantly.
Because there's so many of them.
Exactly. That is what a GPU does. It processes massive amounts of data in parallel.
Okay, that makes perfect sense.
Yeah.
So the U.S. companies are drawing the blueprints for the stadium and figuring out how to organize the 10,000 students.
Exactly right.
But why is it so hard to actually build the stadium? Why does the U.S. have to send those blueprints all the way to Taiwan or South Korea?
Because the manufacturing of these chips, a process called lithography, is arguably the most complex manufacturing process ever achieved by human beings.
Really?
Ever. We are talking about printing billions of microscopic transistors onto a slice of silicon.
Billions?
Yes. And these transistors are measured in nanometers. To give you scale, a single strand of human hair is about 80,000 nanometers wide.
Okay.
The transistors on these chips are sometimes 3 nanometers wide.
I can't even picture that. It's atomic level.
It is practically at the atomic scale. The manufacturing requires facilities called fabs, which cost upwards of $20 billion just to build one.
$20 billion for a factory.
Yes. And they require clean rooms that are thousands of times cleaner than a sterile surgical operating room. A single speck of dust can ruin an entire batch of chips. They use specialized lasers generated by dropping molten tin and shooting it with a high-powered laser to create extreme ultraviolet light, just to etch the patterns onto the silicon.
That sounds like science fiction.
Yeah.
You are shooting molten tin with lasers to print microscopic lines.
It is engineering pushed to the absolute edge of physics.
That is insane.
It really is. Now, over the last few decades, the U.S. companies realized that building and maintaining these $20 billion fabs was incredibly capital intensive.
I mean, yeah.
So they moved to a fabless model. They kept the highly profitable design work in the U.S. and outsourced the physical manufacturing to specialized foundries in Asia, primarily TSMC in Taiwan and Samsung in South Korea.
Ah, see.
Those companies spent decades and hundreds of billions of dollars perfecting the dark art of manufacturing at the nanometer scale. You cannot just replicate that overnight by throwing money at it.
Because it's not just money, it's know-how.
It takes decades of institutional knowledge.
Which brings us perfectly to country number 6 on our global map, South Korea.
Yes.
South Korea's position in this ecosystem seems completely disproportionate to its geographic size. They're listed as an absolute giant in the electronic space.
South Korea's role is fascinating and absolutely vital to the entire global structure.
The data highlights global leaders like Samsung and SK Hynix. And it says South Korea is a critical linchpin in the global supply chain, specifically because they produce advanced memory chips.
Memory, yes.
And it notes these memory chips are absolutely essential for AI systems. Why is memory so important? If the GPU is the stadium full of students doing the math, what does the memory chip do?
Let's stick with the stadium analogy. You have 10,000 middle schoolers ready to do math, but how do you get the worksheets to them?
Oh.
If you only have one narrow doorway into the stadium, it doesn't matter how fast the students are, they're going to spend most of their time sitting around waiting for someone to hand them the next piece of paper.
So they are bottlenecked by the delivery of the data.
Yeah, precisely. In a computer, the memory RAM is what feeds the data to the processor. As GPUs became incredibly fast at processing data, the traditional memory chips couldn't feed them data fast enough. The processor was starving for data.
That makes total sense.
So the industry had to invent a new type of memory called HBM, or high bandwidth memory.
High bandwidth memory.
It involves physically stacking memory chips on top of each other and connecting them with microscopic wires to create a massive wide highway for data to travel directly into the GPU.
So South Korea isn't just making the storage, they are building the massive data highways that keep the AI engines from stalling out.
Exactly. You can design the best, fastest processing unit in the world in California, but if it doesn't have the advanced memory manufactured in South Korea to feed it data at blistering speeds, that processor is effectively useless.
Wow.
South Korea dominates the global production of this high bandwidth memory. They sit at an incredibly strategic choke point.
And we really need to emphasize the sheer scale at which these chips are being consumed. Because I was reading through the material and the numbers regarding these AI supercomputers, the machines required to train the massive models we see coming out of the US and China. The scale is terrifying.
It is hard to comprehend.
The material notes that a single system, one supercomputer cluster, can use over 200,000 AI chips.
Yeah.
200,000 of these advanced, practically atomic-level processors, all wired together to work in unison.
And each one of those individual chips is incredibly expensive and, more importantly, requires a staggering amount of electrical power to operate.
Right. If you have 200,000 chips running at maximum capacity, how do they not just melt through the floor?
Heat dissipation is actually one of the primary engineering challenges of the AI era.
Really, just keeping them cool.
Oh, yeah. When chips process data, they generate heat. 200,000 chips generate an industrial amount of heat. You can no longer just blow cold air over them with a fan.
Right, that won't cut it.
These data centers are having to use liquid cooling. They are literally pumping specialized liquids directly over the processors to carry the heat away.
Unbelievable.
The material explicitly states that data centers are becoming the physical backbone of AI economies. You cannot just build one of these supercomputer clusters in a random office park.
No.
You need dedicated power substations. You need access to millions of gallons of water for the cooling towers. You need structural engineering to handle the sheer weight of the server racks and the liquid plumbing.
Here's where it gets really interesting for me.
Yeah.
Because if we completely abandon the idea of AI as an invisible software brain, and we start looking at it strictly as a massive, power-hungry industrial factory, then these semiconductor chips are the literal engines inside that factory.
Yes.
Without them, the factory sits entirely idle. So I have to push back on the standard geopolitical narratives we always hear on the news.
Okay, push back.
We spend all our time thinking of the US and China as the only two superpowers locked in this epic binary battle. But doesn't this hardware reality, this absolute physical reliance on a hyper-concentrated manufacturing base, I mean, a country like South Korea actually holds the keys to the entire global kingdom.
It's a huge point.
I mean, if Samsung and SK Hynix stop producing that advanced memory, doesn't the U.S. gold rush and the Chinese mega project both grind to an absolute screeching halt?
It is a profound vulnerability in the global system, and it is exactly why experts no longer view this as just an economic trade dispute. It is a global chip war.
That chip war.
You're absolutely right. South Korea, alongside Taiwan, sits at the very fulcrum of this entire global race.
They hold the cards.
They do. The tech giants in the U.S. can have $1 trillion in cash ready to spend, and they can design the most brilliant chip architecture imaginable. But if the foundries in Asia cannot physically manufacture them or refuse to sell them the memory, the entire global AI industry freezes in its tracks.
It's like having $1 trillion to buy cars, but nobody in the world knows how to make tires.
Exactly. And this vulnerability is why nations are drastically shifting their policies. They are no longer treating semiconductor independence as a matter of economic policy or simple trade balances.
It's way bigger than that.
They are treating it as an urgent, critical matter of supreme national security.
Wow.
When a government realizes that their military intelligence logistics, their economic forecasting, and the industrial automation of their major corporations all rely on an AI system that physically requires a piece of hardware manufactured on a small island or peninsula on the other side of the planet.
Panic sets in.
Panic. You suddenly understand why the U.S. is passing massive legislation to heavily subsidize domestic chip manufacturing. You understand why China is investing hundreds of billions into building domestic foundries.
They are terrified of the bottleneck.
They are. South Korea's leverage in this space is monumental. They aren't just participating in the AI race. They own the asphalt that the track is built on.
That totally redefines what geopolitical power looks like in the 21st century.
Sure.
It's not just about who has the most land or who controls the oil shipping lanes anymore. Power is now defined by the capacity to manufacture nanometer-scale transistors.
It's a whole new world.
It is. But, okay, let's pivot slightly, because we've established the physical reality.
Right.
You can have all the raw materials. You can build the massive data center. You can wire together the 200,000 chip supercomputer. You can secure the dedicated nuclear power plant to run it. And you can secure the memory chips from South Korea.
You have the machine.
Right. But without the human talent, without the actual biological human brains to write the mathematical architecture, to design the training algorithms, to tell those 200,000 chips what to actually do, it's all just incredibly expensive, very hot sand.
Hot sand. That's a good way to put it.
Yeah. All of this hardware necessitates a serious discussion about the intellectual bottleneck, the brain power driving it.
Hardware and infrastructure are just potential energy. Human talent is the spark that makes it kinetic.
Ooh, I like that.
And that brings us to a completely different tier of nations on our global map. These are the countries that are dominating the foundational research and the global talent race.
Exactly. And the first country we have to look at here is the United Kingdom.
The UK.
The material describes the UK as an absolute research powerhouse. Now, they don't have the pure financial muscle of the U.S., and they don't have the massive state-directed manufacturing apparatus of China.
No, they can't compete on that scale.
Right, but they have an incredibly outsized impact on the actual fundamental science of AI. The UK is home to cutting-edge AI labs, most notably DeepMind.
DeepMind is huge.
Huge. They have a massive academic research output from universities like Oxford and Cambridge. And crucially, the data highlights that the UK has a very specific, deliberate focus on the regulation, the standard setting, and the ethical frameworks of AI.
And if we are talking about fundamental research, we absolutely have to pair the UK with Canada.
Yes, Canada is a huge piece of this puzzle. The material frames Canada as the early AI research pioneer.
They were there from the start.
They were laying the intellectual groundwork for this technology long before AI was a trillion-dollar commercial industry. Cities like Toronto and Montreal became massive AI research hubs years ago.
True.
And similarly to the UK, Canada has a very strong academic ecosystem, heavily government-funded research programs, and a specific focus on foundational theoretical models rather than just pure, immediate commercial scaling.
Right.
So before we talk about their geopolitical strategy, can you explain what they were pioneering? The material keeps mentioning deep learning and foundational models. What does that actually mean?
This is crucial to understand. Let's go back to how traditional computer programming works.
Okay.
Historically, if you wanted a computer to do something, say, recognize a picture of a cat. A human programmer had to write thousands of lines of explicit rules.
Like, look for fur.
Right. If you see two pointy triangles on top and a long tail and whiskers, it is a cat.
Hmm.
But the real world is too messy for rigid rules. Cats come in different shapes, lighting changes, angles change.
You can't write a rule for a blurry cat.
Exactly. Traditional programming failed at complex pattern recognition.
Because you can't manually write a rule for every possible variation of a cat in the universe.
Exactly. So researchers conceptualized something called neural networks, which are very loosely inspired by how the human brain works.
Neural networks. Okay.
Instead of giving the computer rigid rules, you create layers of artificial neurons. You feed the system millions of pictures of cats and millions of pictures of things that are not cats.
Just bombard it with data.
Yes. The first layer of the network might just look for edges. The next layer looks for shapes. The next layer looks for textures. Through a process of trial and error adjusting the mathematical weight of connections between these layers, the system effectively teaches itself what a cat looks like.
It learns.
That process, using many deep layers of artificial neurons, is called deep learning.
And Canada was the one championing this.
Yes. For a long time, the broader computer science community thought neural networks were a dead end. Oh yeah. They were too computationally expensive and didn't seem to work well. But the Canadian government and specific research institutions in Toronto and Montreal kept funding the scientists who believed in this approach.
They stuck with it.
They kept the lights on during what was known as the AI winter. And when GPUs finally became powerful enough to process those millions of images quickly, it turned out the Canadians were right all along.
Wow.
Deep learning is the mathematical foundation of almost every single modern AI breakthrough we see today.
That is incredible. They essentially invented the modern engine while everyone else was trying to build a better horse.
That's exactly it.
And the UK is doing similar foundational work, right?
You mentioned DeepMind.
Yes. What you are seeing with the UK and Canada is a focus on the absolute bedrock of scientific discovery. DeepMind in the UK, for example, isn't just known for releasing a consumer chatbot. They are known for tackling massive, fundamental scientific problems.
Like what?
For example, they developed an AI system called AlphaFold, which essentially solved the protein folding problem in biology. Break that down for me. Why does protein folding matter?
Proteins are the building blocks of life. Every disease, every bodily function relies on how these complex protein molecules physically fold themselves into three-dimensional shapes.
Okay.
For decades, scientists struggled to predict how a protein would fold based on its genetic sequence. It was incredibly slow, painstaking lab work. DeepMind built an AI that could accurately predict the 3D structures of hundreds of millions of proteins in a matter of days.
In days.
Yes. It essentially mapped the building blocks of biology, opening up entirely new frontiers for drug discovery and medical research.
Okay, so the intellectual output of these countries is staggering. They act as the fundamental research and development laboratories for the entire world.
Very much so.
But this ties directly into a major conflict identified in the material. The global talent race. Countries are competing desperately, and desperately is the exact right word here, to attract the data scientists, the machine learning engineers, and the mathematicians who understand this deep learning architecture.
It's a gold rush for brains.
Yeah. The material notes that while Canada is an emerging major talent hub, the U.S. still relies incredibly heavily on attracting the absolute best global talent to maintain its #1 spot.
They import the genius.
So I'm looking at this dynamic, and I have to push back on the strategy of the UK and Canada.
Okay, let's hear it.
If the U.S. and China are the massive construction firms we talked about earlier, pouring millions of tons of concrete and building skyscrapers, then the UK and Canada sound like boutique architectural firms.
Drawing the blueprints.
Yeah. They are sitting in their quiet offices, drawing the brilliant blueprints that everyone else is using to build the massive buildings.
Right.
Is it actually sustainable for places like Canada and the UK to focus so much on foundational research? Or will they eventually just get completely steamrolled by the sheer financial force and aggressive commercialization of the US and China?
It's a risk.
I mean, you can fund the scientists who invent deep learning, but if a tech giant in Silicon Valley monetizes it to the tune of $1 trillion, did Canada really win the race?
This raises an important question, perhaps the single most important question for mid-sized economies in this space.
Yeah.
What is the long-term geopolitical value of foundational research versus rapid commercialization?
Right.
To your point, it is incredibly difficult for a boutique architectural firm to compete on pure revenue with a global mega developer.
You just can't.
However, the influence and strategic importance of the UK and Canada cannot be understated.
How so?
First, foundational research generates the core patents. The foundational models they develop are the intellectual property that the rest of the world has to license, adapt, or build upon.
Okay, so they own the IP.
Second, and this is where the UK's strategy is particularly shrewd, by focusing heavily on standard setting and regulation, they're attempting to write the global rules of the road.
Wait, how does a smaller economy dictate the rules to a superpower?
Through market access and international frameworks. If the UK can establish the definitive, internationally recognized safety standards and testing protocols for how an AI system is allowed to operate in sectors like finance or healthcare, then even the massive tech giants in the US and China will have to adapt their models to meet those standards if they want to do business in the global market. The UK is betting that the country that writes the safety regulations essentially controls the deployment of the technology.
I see. They aren't trying to build the biggest car. They're trying to write the traffic laws.
Precisely.
Like,
But you highlighted a highly critical vulnerability in your architectural firm analogy, the talent drain.
the brain drain.
Yes. The material explicitly notes that the U.S. maintains its massive lead largely by pulling the best global talent into its ecosystem. The existential risk for Canada and the UK is that they spend millions of dollars in public funds educating the brightest mathematical minds, funding their early research, only to have those scientists poached the moment they make a breakthrough.
Because a Silicon Valley tech giant can swoop in and offer a 25-year-old researcher a $5 million starting salary and access to a supercomputer that the Canadian university simply cannot afford.
Exactly. Maintaining a sovereign intellectual ecosystem when your primary export is pure brain power is a delicate, profoundly difficult balancing act. You have to create an environment where the researchers want to stay, either through patriotic duty, incredible quality of life, or by fostering a domestic startup scene that can actually compete for capital.
It's a fascinating tension.
Hmm.
The massive engines of the US and China fundamentally need the world's best brains to maintain their lead. And the rest of the world is desperately trying to figure out how to keep their own brains at home.
It's a tug of war.
But not every country is trying to build fundamental neural network architecture or compete with Silicon Valley on software.
No.
While the UK and Canada focus on the theoretical science, and the US and China focus on massive infrastructure scale, other nations on our map are taking a completely different, highly pragmatic route.
A very practical approach.
They are aggressively applying AI, strictly to their existing historical and industrial strengths. They are looking at AI not as a shiny new software product to sell to consumers, but as a heavy industrial tool to solve real-world physical problems in sectors they already dominate.
These are what we might call the specialists. And frankly, they represent a very smart, very resilient approach to surviving this technological revolution.
Exactly. And the absolute prime example of this in the material is Germany.
Germany.
Germany is ranked number 4 globally.
Yeah.
And they are described distinctly as the industrial AI leader. They are investing around $11 billion in AI in 2025.
11 billion.
Now, $11 billion is a massive amount of money, but it is obviously a fraction of the U.S.'s $470 billion.
A drop in the bucket compared to that.
Right. But what Germany is doing with that $11 billion is entirely different. They have major historic institutions like the Max Planck Society and the Fraunhofer Society driving this research.
Yeah.
And the material explicitly contrasts Germany with the U.S. model.
Yes, very clearly.
While the U.S. is deeply obsessed with consumer AI, the flashy chatbots, the AI image generators, the software that lives on your phone or in your web browser, Germany is focusing almost entirely away from the consumer.
We don't care about the chatbots.
They are focusing heavily on industrial physical applications. We are talking about advanced robotics, automotive AI, complex logistics optimization, and what they refer to as Industry 4.0.
Industry 4.0 is a crucial concept here.
Tell me about it.
It essentially refers to the complete digitization and AI integration of heavy manufacturing. And this strategy makes perfect sense for Germany. Look at their history.
They make stuff.
They are a historic, unparalleled manufacturing and engineering powerhouse. They build the precision machines that build the world. They are looking at the AI revolution and saying, We don't need to try and build the next consumer search engine. We don't need an AI that can write poetry.
We need an AI that can build cars.
Exactly. We need to build a factory that can predict its own maintenance failures before they happen.
What does that actually look like in practice? An AI factory.
Imagine a massive automotive manufacturing plant. Traditionally, an assembly line moves at a fixed speed, and if one robotic welding arm breaks down, the entire multi-million-dollar line stops until a human fixes it.
You lose money every second.
Huge amounts. In an Industry 4.0 factory integrated with AI, every single machine has hundreds of sensors. The AI is constantly analyzing the microscopic vibrations and temperature fluctuations of the welding arm.
Wow.
It predicts that a specific gear will fail in exactly 72 hours. It automatically orders the replacement part, schedules a maintenance robot to swap the gear during a planned 15-minute shift change, and reroutes the assembly line dynamically so production never stops.
That is seamless.
Furthermore, the robotic supply carts are constantly negotiating with each other in real time on the factory floor to find the most efficient physical path to deliver materials.
That is incredible. They're basically giving the entire factory a central nervous system.
Exactly. And right alongside Germany, taking a very similar specialist approach is Japan.
Right. Japan is highlighted as the robotics and smart technology leader. Now, Japan has always been synonymous with robotics and automation.
Forever.
But now, they're backed by a comprehensive government AI strategy and advanced supercomputing infrastructure to combine that traditional world-class mechanical engineering with deep learning.
A powerful combination.
But what is really unique about Japan's strategy is the why. The material notes that Japan is heavily focusing its AI development on healthcare, elderly care, and automation to solve specific, highly pressing societal problems.
Yes, the demographics.
Japan is facing a massive demographic challenge. They have a rapidly aging population and a severely shrinking workforce. They aren't building AI just to increase quarterly profit margins for software companies. They're building AI to literally physically care for their elderly citizens and to keep their physical society functioning when they don't have enough young humans to do the jobs.
It is an incredibly targeted, necessary application of the technology. They are taking this immense computational power and pointing it directly at their most existential demographic threat: survival.
It really is. If you don't have enough young nurses to lift elderly patients out of bed, you need to develop advanced robotic exoskeletons powered by AI that can safely and gently perform that task. If you don't have enough young farmers, you need AI-driven autonomous tractors that can manage crop yields.
So if I'm looking at the strategies of Germany and Japan, essentially they are outfitting their traditional physical economies with an AI exoskeleton.
I love that phrase.
They are taking the bodies they already have, their steel factories, their hospitals, their car manufacturing plants, and strapping this massive digital AI engine to it to make it stronger, faster, and more efficient.
Exactly.
Which leads me to question the whole premise of the AI race as we usually talk about it. Is it ultimately smarter in the long run for a country like Germany to just completely ignore the flashy consumer AI race?
It might be. Should they just completely abandon the idea of building a European competitor to ChatGPT, let the U.S. tech giants burn hundreds of billions of dollars fighting over who has the best chatbot, and focus entirely, 100%, on dominating the factory floor?
It is a deeply strategic question, and frankly, I think the specialist approach is brilliant for a country with their specific industrial base.
Why?
Let's analyze the long-term economic implications. The consumer AI space, particularly the software we interact with on our screens, is incredibly volatile.
Super volatile.
It is subject to massive hype cycles, rapid and unpredictable shifts in consumer behavior, and intense cutthroat competition. A tech company can spend $10 billion in 2 years developing a massive consumer model, and 6 months later, an open source competitor releases something functionally identical for free, instantly destroying the business model.
The barrier to entry for someone switching chatbots is zero. You just close one tab and open another.
Exactly. The switching costs are non-existent. But integrating AI deeply into heavy manufacturing, into physical robotics, into national healthcare infrastructure, that yields incredibly sticky, stable, long-term economic resilience.
Sticky, meaning
Yeah.
it stays put.
Yes. Once a massive German automotive company physically integrates an advanced AI system that makes their global manufacturing 20% more efficient, That is a hard, physical, deeply entrenched economic advantage. A competitor cannot disrupt that overnight with a clever software update.
Right, they can't just download a better factory.
They would have to physically rebuild their entire factory to compete. I would ask you, the listener, to think about this in the context of your own life and the broader economy.
Yeah.
A new AI chatbot might be fun to play with. It might help you write an email faster or summarize a document. But an AI system integrated into your local hospital that can accurately predict a patient's deterioration hours before a human doctor could spot the vital signs.
Life-saving.
Or an AI deeply embedded in a logistics network that keeps the global supply chain from collapsing during a pandemic crisis. That impacts your daily life, your physical health, and your economic stability far more immediately and profoundly than the software trends dominating the tech news cycle. Germany and Japan are placing their bets on the physical, tangible world.
That makes total sense. They're building a massive physical moat around the industries they already do best.
Absolutely.
But even if you have a great specialty like Germany, or if you are a research pioneer like Canada, or even if you have a massive talent pool, we are seeing a shift in the global understanding of this technology.
A big shift.
Countries are realizing that being really good at just one specific thing isn't going to be enough to survive the coming decades. They're realizing they need to build entirely self-sustaining, robust ecosystems. They need to control their own destiny across multiple layers of the stack.
You can't just have one piece of the puzzle.
And that brings us to the final section of our global map. Let's look at three very different countries in very different geopolitical and economic situations who are all trying to build resilient ecosystems.
This is where we see the global strategies diversify even further, tailored almost entirely to the unique geographical, cultural, and demographic realities of these specific nations.
First, let's look at India. The material describes India as the fastest-growing emerging AI superpower on the board.
Fastest growing.
They're projecting an AI economy worth a staggering $500 billion by the year 2030.
500 billion.
That is an explosive rate of growth. And their unique, massive advantage is their talent pool. They have an unbelievably massive population of highly educated engineers and developers.
Demographics again.
Right. But I want to know how they are turning that population into an ecosystem. Because it isn't just raw talent floating in the ether. The data highlights government initiatives like the India AI mission, which is creating public-private collaborations. And critically, they are experiencing a massive expansion of AI data centers and physical cloud infrastructure, which is being fueled by billions of dollars pouring in from the global tech giants like Google, Amazon, and Microsoft.
Foreign money.
Exactly. So I'm looking at India's numbers, and they are projecting massive growth, but how are they actually executing that without the massive domestic capital of the U.S. or the state funding of China?
India is brilliantly utilizing what economists call its demographic dividend.
Demographic dividend.
They have the human capital required to do the massive amounts of foundational work required for AI. People often forget that before an AI can learn, the data has to be prepared.
Oh, the messy part.
Yes. Millions of images, texts, and audio files have to be cleaned, categorized, and labeled by human beings. India has long been the global hub for IT services and data processing at an unimaginable scale.
So they're doing the heavy lifting of the data preparation.
Yes, but they are rapidly moving up the value chain. They aren't just labeling data anymore. Their engineers are building the applications and fine-tuning the models. But to your question about capital, India knows they cannot outspend the U.S. government on physical infrastructure.
Right.
So the India AI mission is designed to make the country an incredibly attractive place for foreign tech giants to build. Google and Microsoft need access to India's massive consumer market and their engineering talent.
They want in.
They desperately want in. In exchange, India requires those giants to physically build the data centers and cloud infrastructure on Indian soil. India is essentially leveraging its massive population to force foreign capital to build its domestic physical infrastructure.
That is a fascinating strategy. They are trading market access and human capital for physical concrete and servers.
Exactly. By partnering with global tech giants to build the physical infrastructure domestically, they are rapidly closing the gap between being a source of outsourced labor and becoming a sovereign AI power in their own right, capable of running their own massive compute clusters.
And speaking of sovereign AI, that brings us perfectly to France.
France is a very interesting case.
France is emerging as Europe's rising AI star. And the phrase the material uses over and over again that really stands out is sovereign AI capabilities.
Sovereign AI.
France is focusing heavily on building sovereign AI to protect European data and independence. They have strong government support, they're investing in supercomputers, and they have a rapidly growing startup ecosystem, with companies like Mistral AI making major waves on the global stage.
Mistral is doing great work.
But I need you to explain this concept of sovereign AI to me. Why does France care if an AI model is French or American? Isn't math just math?
You'd think so.
Right. Why is France so desperate to make sure Europe isn't entirely dependent on American or Chinese models for their technological future?
It is a phenomenal question, and it goes to the very heart of what an AI model actually is. Math is math, yes. But an AI model, specifically a large language model, is not just a calculator. It is a mathematical representation of the data it was trained on. Think about it this way. If you train an AI model entirely on data from the United States, American books, American news, American internet forums, that AI will inherently adopt an American worldview.
Oh.
Its understanding of history, its moral weightings, its cultural references, and its legal understanding of concepts like privacy or free speech will all be deeply, fundamentally American.
Oh, wow. I had thought about that. The data carries the culture.
Exactly. The data encodes the culture. If a French citizen asks an American AI about a specific historical event, it will give an American-centric answer. If a European corporation asks an AI to draft a contract, an American AI might structure it based on U.S. legal norms, not European law.
That's a huge problem.
It is. France, and by extension the broader European Union, deeply recognizes that relying on foreign AI models is a form of cultural and intellectual surrender.
Surrender. Wow.
They recognize that an AI trained by a corporation in Silicon Valley will prioritize different values than an AI trained in Paris, and certainly different values than an AI trained in Beijing.
And there's a data privacy angle to this too, right?
A massive one. The EU has very strict data privacy laws.
GDPR.
Exactly. If European hospitals, banks, and governments are using AI models hosted on servers in the United States, there is a fundamental risk regarding where that sensitive data is going and who has access to it.
Right.
Sovereign AI means building the models on European soil, using European data, trained by European engineers, running on data centers physically located in Europe, subject to European law. It is both a defensive strategy to protect their culture and data, and an offensive strategy to ensure they aren't left behind economically.
They want to make sure the artificial intelligence making decisions for French citizens actually thinks like a French citizen. That makes total sense.
Exactly.
Which provides a perfect contrast to our final country on the global map, Israel.
Israel.
Israel is ranked number 10, and the material paints them as the ultimate startup and innovation hub. They obviously do not have the massive billion-person population of India or the sheer trillion-dollar capital of the U.S. or the massive industrial base of Germany.
Yeah.
But their strength lies in extreme agility. The data highlights that they have an incredibly high concentration of AI startups, a significant influx of global venture capital, and a very unique, highly efficient integration between military tech and civilian AI. They are particularly dominant in applying AI to cybersecurity.
Israel represents the absolute power of hyper-dense innovation networks. Their ecosystem is built on a very specific pipeline.
Right, the military-civilian pipeline. How does that actually work to build an AI industry?
In Israel, military service is mandatory, and the military has elite, highly secretive technical and intelligence units.
Okay.
The individuals selected for these units are essentially given world-class training in computer science, cryptography, and now artificial intelligence, often under the pressure of real-world, high-stakes national security operations.
A trial by fire.
Extremely so. When these individuals finish their service, they enter the civilian sector with incredibly advanced technical skills, deep experience in working on high-pressure teams, and a vast network of highly skilled peers.
And then what?
They immediately found startups, and because the geographic area is so small and the tech community is so tightly knit, venture capital flows incredibly efficiently to these founders.
So they take the intensity and the cutting-edge tech of military intelligence and instantly commercialize it.
Precisely. And that is why they are so dominant in areas like cybersecurity. When you have a pipeline of talent that has literally been trained to defend national infrastructure from advanced state-sponsored cyber attacks,
They know how to build the shield.
yes, they are perfectly positioned to build the AI tools that defend banks and corporations from those same threats. They have a speed of iteration, the ability to identify a problem, build a startup, develop an AI solution and deploy it that is very hard for larger, more bureaucratic nations to match. They are incredibly fast.
Okay, let me synthesize these three very distinct ecosystem models.
Sure.
You have India, which is building a massive, scale-driven domestic engine fueled by sheer demographic power and leveraging foreign infrastructure. You have France, which is building a protective, highly regulated fortress of sovereignty to safeguard European data, culture, and values.
Yep.
And you have Israel, which is acting as this highly agile, rapid response strike team focused on hyper-niche, incredibly technical areas like cybersecurity.
That's a great summary.
So, here's the question I want to throw at you. If you are the leader of a mid-sized developing nation right now, and you are watching this massive trillion-dollar global race unfold, which model do you try to copy?
Oh, wow.
What is the actual blueprint for survival here? Do you try to build scale like India, knowing you probably don't have a billion people? Or do you try to build hyper-niche agility like Israel, knowing you might not have their venture capital network or military pipeline?
If we connect this to the bigger picture, the blueprint isn't actually about choosing to copy one specific country's model.
It's not.
No. The real blueprint is found in understanding the foundational elements that all of these successful nations are trying to secure. The material points toward 5 absolute pillars of an AI ecosystem. Success in this new era is no longer about just having one advantage. It requires all 5 distinct elements to harmonize.
What are the 5 pillars?
Data, compute power, talent, capital, and policy support. The countries that will survive and dominate are the ones that can successfully combine all 5 of these elements.
All 5.
If you are a developing nation trying to build a strategy, you can't just say, let's be like Israel. You have to look at those 5 pillars and ruthlessly assess your own national inventory.
Take stock.
Exactly. First, data. Do you have access to large, high-quality, localized data sets to train models? Second, compute power.
Yep.
Can you secure the actual hardware? Can you navigate the geopolitics to import the advanced chips? And do you have the energy grid to power the data centers?
Physical stuff.
Right. Third, talent. How are your universities structured? Are you educating engineers? And more importantly, do you have an environment that prevents them from immediately leaving for Silicon Valley?
Stopping the brain drain.
Fourth, capital. Where is the money coming from? Is it state-funded, or do you have a private venture ecosystem? And finally, policy. Does your government regulation accelerate this growth, or does bureaucracy choke it out?
That's a huge checklist.
It is. True dominance, or frankly even just long-term economic survival in this space, requires a deliberate, unified national strategy to build and connect all 5 of those pillars simultaneously. You cannot just have brilliant engineers if you don't have the compute power for them to test their theories.
Right.
You cannot build massive data centers if you don't have the policy support to secure the water rights for the cooling systems.
Yep.
It is an intricate, deeply interdependent web.
Which brings us right back to the sheer, overwhelming complexity of what we are dealing with. As we synthesize all of this material, the core theme leaping out of every single country's strategy is acceleration.
It's only getting faster.
The competition is not slowing down. It is speeding up exponentially. We are looking at a future where trillions of dollars are expected to be deployed into this specific sector by 2030. Trillions.
Unimaginable wealth.
And the nations that master this incredibly complex integration, the ones who can balance the heavy infrastructure, navigate the geopolitical chip wars to secure the hardware, fund the foundational research, and retain the elite human talent, those are the nations that will entirely define the next era of global dominance.
Absolutely. The geopolitical map of the 20th century was drawn by access to oil, control of natural resources, and dominance over strategic oceanic shipping lanes.
Maps we all know.
Right. But the geopolitical map of the 21st century is currently being drawn right in front of us by access to compute power, control over advanced semiconductor manufacturing, and the human capital required to wield those tools. The stakes are nothing less than total economic and technological hegemony for the next century.
So what does this all mean? We've spent this entire time talking about billions of dollars, nanometer scale transistors, advanced supercomputers, and massive geopolitical strategies.
A lot of high-level stuff.
Yeah. But bringing it right back down to you, the listener, understanding this global map isn't just an exercise in high-level geopolitical trivia. It is about understanding the literal mechanics of your own future.
It affects everyone.
This global race determines exactly where the high-paying jobs of the next 2 decades will be created. It determines how the global supply chains that deliver your food and medicine will shift, break, or reorganized.
Definitely.
And most importantly, as we saw with France's strategy, it determines who will write the rules, the cultural ethics, and the literal mathematical code for the technology you will interact with every single day of your life.
The rules of the road.
The AI systems that will diagnose your illnesses in the hospital, the algorithms that will manage your retirement finances, and the physical AI that will optimize the city grid you drive on. Those will all be the direct products of these massive national strategies we've discussed today.
The physical infrastructure being built today will dictate the boundaries of human capability tomorrow.
Exactly.
Mm.
And that leaves me with a final really provocative thought from looking at this entire global landscape, something I want you to just mull over.
Yeah.
We've spent this entire deep dive talking about the top 10 countries. We talked about the heavyweights like the US and China, the specialists like Germany and Japan, the pioneers like the UK and Canada.
The leaders.
But there are almost 200 countries on this planet.
Right.
If these top 10 nations successfully hoard all the advanced manufacturing for chips, if they consume all the massive compute power and the energy required to run it, and if they vacuum up all the elite global talent from every university on Earth, what happens to everyone else?
That is the trillion-dollar question.
Are we rapidly heading toward a completely new kind of global divide? A world that isn't separated by geography or natural resources or even traditional financial wealth, but a world divided entirely based on who has access to artificial intelligence and who is locked out.
A digital divide on steroids.
Exactly. Let that reality chew on you for a bit. Because when tech giants and superpowers are dropping $600 billion a year on the physical foundation of this new world, you can be absolutely certain to one thing. They aren't building it for everybody.